Hi, it's Z here, and welcome back to the final video in this three-part video series. And in this particular video, I'll be talking about my key takeaways, having attempted to build and deploy this simple machine learning web app. And I have five key takeaways that I came up with, and they're not mutually exclusive. Some of them kind of overlap with each other, but I'll walk through each one. So first one is a bit of an obvious statement, but understanding your training data really is very key. Um, for the image model, I started with 1,000 epochs, and I wasn't really getting the results that I wanted. But even after 1,000 epochs of running the model, what I ended up with was something that didn't look anything like a image. I decided to increase it to 10 times that amount. So this is 10,000 epochs. Um, there was a bit of an improvement, but after 10,000, it still looked kind of weird. Didn't really look like anything in particular. And it could be that the data set was too small. I only had about 200 images. Maybe I could have done more pre-processing in terms of things like adjusting the color, cropping the images. But I have a niggling suspicion that maybe there were no defining traits across the entire data set that the network could learn from. And what I mean by that is if you look at the raw images themselves, there is a lot of variety. And I think even a human being would be hard placed to try and figure out a common pattern behind each of them because this is not a simple task of training a network against a set of faces, but you've got so many different types of posters. So one idea that I did not explore was whether or not I could subcategorize the posters into different archetypes and maybe make it a bit easier for the model to learn. Uh, Maybe it's something that I'll try next time. I don't know. Uh, and even for the simpler text generation model, uh, the pre-processing step was something that I didn't really spend too much time trying to optimize. Messed around with it a bit. So what I mean by that is when you generate the tokenization, you can choose the number of words that you want to tokenize, and I arbitrarily chose 2,500. What this led to was quite a large number of permutations in terms of potential sequences, but maybe a smaller number could have actually worked better. Having said that, with the text model, I did try with 1,000, and the results look pretty much the same. So wasn't really sure what lever to pull to make the results better. But the end result is you really do need to understand the data that you have that you're going to be using for training. Now, the second lesson is that deep learning is hardware intensive. Um, the image model, especially, training just 1,000 epochs took almost 8 hours. And I mentioned in the previous video, I went and looked for a cloud-based ML ops platform to do this. And uh, it's also the code that you use. So the generative adversarial networks appear to be really difficult to train because you're having two different networks and you're combining them into a single model and training them in tandem. And I've done some reading and I'm pretty sure that there are ways that you can optimize it to make it less computationally intensive, but I did not pursue this either. Um, Part of the challenge with working with these sort of large clunky models of millions and millions of parameters is that uh, making adjustments, even changing one of these, say, hyperparameters in terms of, say, example, uh, how many layers or what's the size of the kernel, how many kernels to have per layer, you have to take quite a long time to see what it does to the end results. So I guess I sort of knew this intellectually, but it really became a practical problem when I was messing around trying to change one or two variables, which is a nice segue that leads me to my next point. Uh, Deep learning requires quite a lot of expertise to really do right. So you can really tell by watching the previous two videos that um, most of my code has been copy pasta of sample code that other people made. But there was a lot of stuff that I experimented with to try and understand better, and I'm still learning, I guess. I mean, it could be things like let's start with the simpler model for the text generation. How many nodes the LSTM had and the number of dimensions for the word embedding layer. I didn't mess around with that because I basically stuck to the sample code that I got, and I kept to 64 dimensions for the word embedding and 20 nodes for the LSTM. Maybe an idea would be for the Sypnosis model, especially because the number of tokens were higher. I could have increased this. It's not something I tried though, but the again, going back to my earlier point about how the more complicated you make the model, the longer it takes to run. Selection of learning rates was also something that I didn't really explore. I did change the learning rate to a larger number, and as expected, I got a result faster, but it didn't look like the model was converging in terms of reduction in loss. Um, and more fundamentally, the loss function itself. I mean, I've got two sample texts here. One is after one epoch, and the other one is after 100 epoch. And I mean, you can see that it's got an improvement in accuracy and in loss. But when you read the actual samples themselves, they both look kind of the same. So it's hard to interpret what the loss function and the accuracy actually really mean for text generation. I also didn't bother with early stopping or dropouts for the simpler text model. Um, and that's just for the very simple four-layer model. When you get to the much more complicated image model, I'll show you what it looks like in a moment, that had a much more complicated architecture. You can see it's got many more layers doing different things. It got a lot harder, and I think I have to admit I was just running it as is without trying to change too much. And I also have a niggling suspicion that uh, I was running into some troubles with the training, and there are quite a number of articles out there about how you can better train a GAN model. And what I found was that the generator accuracy was always being dominated by the discriminator accuracy. Maybe that's the reason why I'm not getting the images that I expected. So the end of it is just cutting and pasting code. Obviously, this can only get you so far, and there needs to be quite a lot of investment in understanding some of the theory and the math behind how the networks work. Now, the fourth lesson that I picked up was there is a trade-off between building your own solution versus using package services. Um, Package services are good, but you'll see in the previous video I already mentioned, for example, in PassHub, you need to pay if you want the feature where you can download images. Uh, so in retrospect, I guess I used all these different pieces to pull it together. I mean, I had PassHub, I had Spell, I ended up with Python Anywhere, uh, and it could have been something I could have done. I could have actually just gone to one of the major cloud players, either Amazon or Google Cloud, and then just used all their package solutions at once. Obviously, it will cost a lot more, but I think they're designed so that the integration is a lot smoother. That being said, the midway solution where I mix and match different services and I used some Python programming to clean up whatever loose ends, it can work. I think the trick is really to be aware of what kind of trade-offs that you're making in terms of costs, in terms of ease of interfacing between the different blocks. And that leads me very nicely to my last point. End-to-end deployment needs quite a wide set of skills. And even if I start at the dataset building perspective, where I was trying to gather some training data, web scraping is a topic all on its own. And an area that I didn't really explore was how to use request headers, proxy IPs, and all this other good stuff so that you avoid getting booted out by the website because you're web scraping. So instead, I had this halfway solution where I instead put a little time delay whenever I open and save an image, and hopefully in that way I look more like a person rather than a robot. But clearly, I mean, this is a big field, and you do need some know-how in order to do it right. And also with Flask, I initially had a piece of code where I was trying to generate the images on the fly from the model and saving it into a temporary file and then deleting it and creating a new image every single time. And I ran into some pretty serious issues with caching because apparently Flask doesn't like having new images each time. So it was a lot simpler just to serve new static files and creating a new file each time. And of course, the biggest one was around the deployment strategy, where uh, I already mentioned in the last video, Python Anywhere doesn't allow TensorFlow to be integrated into the web app. And the anyway, professionally, you wouldn't do it the way that I was going to try it. You would try to split up the model into, I guess, what you call a microservice approach, where you'd have the TensorFlow model sitting in one corner, and you'd have a Flask app that would only be the front end. What this meant though is that there would be a whole bunch of additional learning curve barriers because you got to use other services like Google App Engine, Amazon Lambda, or I think Python Anywhere also had a paid version where you could use Celery to run scheduled tasks or always on tasks to serve up the TensorFlow model. So you saw I ended up with a fake solution that cycles through archive output generated from the models. This kind of worked, but it did feel a bit like cheating. So those were the 5 big lessons, and I guess it brings me to the conclusion. So was it worth the trouble? And short answer is yes. So if I look at what I was trying to do, I definitely learned a few more things about the various steps by trying to do it, and got a bit more familiar with neural networks beyond just doing courses online and cut and pasting code. Definitely had some fun. Um, I guess what you could argue is whether or not this has provided any entertainment to you guys out there. Leave me comments if it has. And I'll leave you with this. My key insight is that there are many different ways to solve a problem. It really does depend on what you want out of it and understanding how the user is going to be making use of your web app. Things like traffic, things like you know reliability, the security concerns, and I guess for the website that I created, I got away with a very sort of cop-out solution because nobody is really relying on the results for anything meaningful, and it, it's it is something that I feel a bit irritated with, but hey, I got the website out there. So that brings me to the end of this video. Um, Let me know in the comments if you think I should try anything else. And thanks for sticking through. Bye now.